So what we're going to do in this video today is we're going to take a look at representing combined probabilities with Venn diagrams and also formula, and also really pay attention to those and or statements. So let's go ahead and jump in. So when we're representing combined probabilities, this means like if event A and B both happen, all right? If it rains and I'm wearing a black jacket or something. Or there's an or event, like it either snows or it rains. If A, then all you could also say like, oh, what's the probability of it not raining? Or hey, what's the probability that it rains given that it snows? Okay, so all are different forms of asking different types of questions. And there's different types of symbols that you need to pay attention to. So the intersection is sort of this N. I always think of that as N as in intersection, the N right there. And that just means and. A and B. What's the probability of them both happening? So if I was to go ahead and do the intersection for A intersect B, that is the middle part right here. That is what the intersection is talking about. That is A intersect B. Now the union, which is represented by the U, is an or statement. It means that events that A or B both happen. So what that means is that I'm talking about A happening or I'm talking about B happening. So it's either going to be in A or it's going to be in B, which means that you're looking at basically everything inside the circles, whether it be both of them, either of them, and not neither of them. You're not taking that one into account. You could also talk about the complement. So the complement of A means not A. So what that means is you're literally talking about not A. So that would be everything in B that's only B because that's not A, and then everything that's outside because that's neither A or B. So there's your complement. And now I have the probability of A given B. The probability that A occurs given that B occurs. So what you're actually going to do is you're going to narrow down your universe, because given that B occurs, you're basically talking about this circle right here. And then what you actually want to find is this sliver right there. But now your denominator is going to be this outside part B. So let's say, for instance, that this was 2 and this was 6. You'd have a probability of 2 out of 6. I'm sorry, 2 out of 8. I apologize. 2 out of 8, which would give you 1 over 4, which is 25%, because you're saying that, hey, given that B happens for sure, which is this entire circle right here, which is 8 different data points, what's the probability of A? Well, you have 2 out of that 8, hence right there. So it seems a little bit complicated, but I promise the more that you get acquainted with it, the quicker it goes. All right. So very quickly, let's take a look that the probability of A plus the probability of not A is equal to 1. Well, that means that I have, well, the probability of A happening, which is this yellow part right here, and then not A, which is everything outside, equals 1. Well, that should actually make sense because either A happens or it doesn't. So the probability of it happening and it not happening would be 100%. The probability of not getting heads plus the probability of getting heads would have to, it has to be one of those. It has to be one of them. Either something has to happen or it doesn't happen. So it's going to be 100% in that case. So now let's take a look at a different example. So let's say that the probability of A, let's say that there's 3 people in A and only A. Let's say there's 2 in the middle between these, and there's 5 that are in B and only B. And let's say, for the sake of argument, that there's 1 person on the outside, and then there's 11 total in this universe. So what's the number of A intersect B? How many people is that? Remember, it's where A and B both occur simultaneously. That'll be 2 different people. Now, what is the probability of A intersect not B? So what that means is the probability of A and not B. That's kind of a weird way of saying A and only A, but it's just saying, hey, where does A intersect not B? And that is right here. So you're looking at 3 different people out of a total of 11. Now, what's the probability of A intersect B, but the complement of that? What's the probability of not A intersect B? Well, one important piece of information is that the probability of something not happening is just 1 minus the probability of it happening. Okay? So if I take the probability of A intersect B, which is going to be 2, what's the probability of, the probability of A intersect B is 2 over 11. So what would 1 minus 2 over 11 be? Well, 11 over 11 minus 2 over 11 is going to be giving me 9 over 11. All right, there's my probability right there. So now I'm given the probability of A union B, but the complement of that. So not A union B. So again, if I want not, I take the probability, I take 1, which is 11 over 11. Now I'm going to subtract the probability of A union B, which would be 3, 2, and 5. That's going to give me 10 all over 11, so that's 1 over 11. There we go. Happy days. All right. So next up is mutually exclusive events. So what mutually exclusive events are events that cannot happen at the same time. So for instance, you are in the class AISL. You cannot, as per the rules of the IB, take AASL at the same time. You can only take one of the math classes. These two are independent of each other. Sorry, not independent, but they are mutually exclusive of each other, meaning they cannot happen. They cannot occur. So what that means is that they have zero overlap. It means that the intersect between these two is 0. So think about this. What is the probability of selecting a student in your school who is taking AISL and AASL? Well, there's going to be 0 kids that do that because it's not allowed. You can't do that. Maybe you can transfer classes, but you cannot take them simultaneously. And so for mutually exclusive events, the probability of one plus the probability of other is the union between the two. And that should make a little bit of sense. So let's take a look at a problem right here. Let's say that Arthur has a drawer which contains ties. So he picks a tie at random from the drawer, and the probability that the tie is blue is 5 over 12, and the probability that's red is 1 over 3. What is the probability of Arthur picking out a tie that is neither red nor blue? So again, a tie cannot be red and blue in this circumstance, right? These are solid color ties, mutually exclusive. So if I drew my little universe box here, and then I drew one circle over, I guess it's an oval, over here and over here, I would have my red tie over here, and I know that that's 1 over 3, and then I would have my blue tie over here, which I know is 5 over 12. So what's the probability of them, well, being neither? So remember, I want the probability of it not being blue or red. So let me take the probability of it being blue or red and just subtract that from 1. So I'd have 1 minus, well, I have 5 over 12 plus 1 over 3, because this right here is the probability of it happening. So I'd have 1 minus, let's see here, that would be 4 over 12, so that'd be 9 over 12. This would be 12 over 12, that gives me 3 over 12, that is going to give me 1 over 4, that's going to give me 25% chance of it not being red or blue. So again, we can use what we learned before in terms of subtracting the probability of something happening from 1 to get the probability of it not happening. And we can still use our Venn diagrams to show really important pieces of information, even if they are mutually exclusive and they have no overlap. So that is what we have for today. Hope you all enjoyed the video. Take care, and I'll see you in the next one.